Yes.
We've been reporting upon 4 years of light pollution documents.
Okay, because a little bit technical problems with this. I start with this. It's something I invented. No, not I invented myself, but I did it the last half year. It's to present how the night is to government, local governments. That's my job. I really work in this field. And so everything I do, it's paid. That's maybe important beginning. And therefore I have a different different background. This is one of the things I do for local governments. How do your environment looks at night? Nobody goes out at night and looks at it. Hey, that's my area where I govern. At the daytime they do, but at nighttime they don't. So this is one of the things I gifted to do. You can, at a lot of locations, I made these kinds of pictures, make them together, including the sky with the stars in it, local things. And also, and there I didn't hear anything about it, the surroundings is not only the sky, but also the horizon. It's very important. We are looking at the horizon at night also. And at this point you see here a lot of lights, and that's important for the quality of this location. My car is all the time in it. That's a problem with this. Okay, now I have to put this out and start my normal thing.
Is that the moon up there?
The moon is there behind the cloud here.
Was it the full moon or present?
I don't know. That's one of the. It's one of the things. There's not only clear nights. Governments are interested not only in clear nights, they are always interested in their things. 80% of the time it's clouds, and 50% of it is the moon. So clear nights are not the main interest for local politicians. All the other things are more. They're interested in the diversity, and in the worst case, and in the best case, but in all different conditions. Okay. Local Dutch provinces, like Doreen yesterday said already, are interested in their local what it looks like at night, and these are questions they have got. Where to put a new industrial site? Have you think about the night problems too in this respect? Is a nature park also good quality at night? Can I improve the night condition in special region? These are questions local government have, and I try to answer them for them. And this is most of the time what they want. What can I do to improve it? They want to have means of it. So this is the things I do. And the problem a little bit is, what is the quality? What is this visual quality? And really, at this point, you see this is the same all sky, and here you see all those lamps, about 250. I counted them, and this is rubbish. You can see this is bad quality because you can't identify even more which exactly is which purpose for each light. It's so much light, it has no structure in it. It isn't helping anybody at this point. So this is bad, you could say. But also the night, the quality of the sky brightness is also then important. So what I do is try to find the amount, strength and locations of all those light sources in a special region, and the amount of darkness, light in the sky, in all directions. In all directions, not only the zenith. I try to do it at least. Okay. If you want to know sources of light, they want to have the means. So they want to have the sources of light where it is. Now, most of the things are already in databases. You can find it. But some I really did go to all strong lighting places. I surveyed them, sports fields, greenhouses, military fields, industrial sites, those kinds of things. I really went there at night and I tried to make a photo of them, try to evaluate their light, not really measuring it. That's a lot of work. I didn't have time for that. And these are the results they've got for special regions. This is a part of Zealand in the southwest of Holland. The blue ones are all the lanterns, the lampposts in the thing. If you go into the GIS, the Geographic Information System, where it's in it's not only a picture, but it's really something in the Geographic Information System. There are all the lampposts. The red ones are provincial lighting, public lighting, and all the stars are the locations I went really to. And the yellow ones are worse, and not the yellow ones are better. So I tried to find, this is a map of the survey of this part of Zealand. I did it for half of Holland now. So this is kind of other things I give to them. These are all sky photos, and this is the thing I just showed you, this panorama you can walk around in, and I skip that now. Okay, then the amount of light of the sky. Darkness varies all the time. It's hardly any time stable. These are often clear things, moons, clouds, etc. Fog. And they are interested in, want to have a stable map. Not only with the moon, but really a stable. They want to have the source, because they want to do something about the light on the ground. So they have to want a stable map of the light pollution. That is Sensano giving, and therefore we are always taking the measurements in the zenith, because it's easy and stable. So I do also the luminosity of the ground is for local governments the most interested. They want to have the amount of light on every special point, but it's hardly to measure. You can't do it. There are always trees in the neighborhood. You can't do it. So I chose to make the luminosity of a special point on the sky. The zenith is then not the worst part. And it's a good parameter for darkness. It's not darkness itself. It's a parameter for it. And this is the normal way to do a luminance metering. And it isn't working very much because the night sky is too dark for it. So therefore we use things like the SQM. But I chose another method because the SQM is too coarse for my purposes. I don't think it's too coarse. You have a lot of stars in it. You measure stars. You measure the Milky Way. You're not only measuring the sky. And I want to measure the sky because the stars are not influenced by local light. Only the sky background is influenced by local lights. And I want to improve the local lights. So this is what I did. It's a method of Falchi and Sensano, and original written for CCD cameras. And I did it with CCDs and different other things. This is the way to do it. You have to calibrate your camera. I did it was this way. This is all the points are measurements of stars, and the air mass is horizontal. So this is low at the sky because it's a measurement there, somewhere there, and you can see the extinction. The result of in your camera is low. Therefore, it is extinct very, very much. And you can see a lot of those measurements on different nights. This is one night, and this is another probably. A lot of them, about 10, I think, and all are therefore. So this is my calibration for my camera. They're all working together to this point. This is one part you have to do. otherwise it doesn't work. And the second one is measuring sky brightness. Make a picture of the zenith, or if the Milky Way is there, a little bit out of the Milky Way, otherwise you get all rubbish. Make it dark, make a calibration each night. So I make every night in different parts of the sky measurements of how much the sky is transparent for stars going down. And analyze, of course. I've done 1,500 measurements in Holland the last 4 years. In this province, Zeeland, in south of Holland, Utrecht, there, and also for local governments there. 1,500 total, in a raster of about 4 kilometers. So every 4 kilometers I took a point and I measured it. And these are some of the results. This is Gelderland. It's in the center. The Veluwe, you heard yesterday about it. This is a natural park. This is a part of our central Holland. This is Rotterdam. Was not allowed. No, it was not true. I didn't get the commission to really measure The Hague and Rotterdam too. They knew it was a lot of light. They were only interested in the dark places. So therefore, I didn't measure these things. Here's The Hague. Here's Rotterdam. Amsterdam is there. So you see the different types of representation. The local governments have made these maps out of all those measurements. I can do it myself, but they chose the colors for it, so the colors are different. And for whole of Holland, I did it this way. These are all the measurements together in this scale. I always thinking in millicandela, because all those zeros are too much. And you can see this is the darkest part of Holland at this moment. And here, I don't know exactly what the light it is, somewhere there, I don't know. Antwerp, I also measured something of Antwerp because it has an influence on Zeeland. Antwerp is Belgium. This is the results. And if you can compare it with the World Atlas, this is, here is Zwolle, that's also the same there. Here is Apeldoorn, it's a big town, 150,000 inhabitants. You can see it there. That's there. So you can see this region is this region. It's comparable, but you will see my results are a little bit more, have more, a bigger smaller raster. Oh boy. Yes. Also, I did some modeling. All the inhabitants get some money, get some light. I gave them to them, and I measured. I said, okay, the law of Walker, very easy. What's happening? And then the Veluwe would be like this, and this was with the darkest point. But in my measurements, it wasn't. This was the darkest point here, and not here. And afterwards, I went there, and what's happening there exactly? And here's a defense organization. It's not on the map for local inhabitants, of course, but it is their influence in the sky brightness. I've got 5 minutes. Okay, try to do it. These are, till now, I've done it as if it's easy. I thought in the beginning it is easy, but it isn't easy. These are all things you have to consider when you do something like this. So you've got the source. Is the source well stable during a night? Is it stable during a year? Snow, for instance. The natural sky luminosity, is it always stable? This light in the atmosphere, it's very complicated. I'll tell you something more. And also the camera, is it working correctly? So some of the red things, I will say something about it. These are the things I use. Most of the time I use a Canon D20, but also to calibrate and to look if it's a correct, also use the CCD. It's much more work. you are not 5 minutes per location or 10 minutes, but 1.5 hours or an hour. So it's a lot of my work, but I do it once in a while to look if my method is still correct. And since short, I've got this apparatus. It's a cooled. This is a part to directly cool the DSLR camera, 25 degrees. And it's diminished a lot of your error. I've not used it regularly in my measurement, but used it as a try to find out if it's better. Yes, 25 degrees temperature. Below the environmental temperature. One of the things is the linearity of these DLSR. Are they enough linear? This is the thing I found. This is horizontal. Is here. This is darkness, and this is light. I get on with my diaphragm and so on. And it's in the beginning it's linear, but at the end, when it's the surroundings get lighter, it stops the linearity. If I do out these three things, then I get a result rather linear, and that's what I find. I use only magnitude 4 and 5 stars in a 30 seconds. 30 second exposure, and 6 magnitude stars and 2 magnitude stars don't work. They get different wrong results. So the linearity of your camera is limited between the lower and the upper limit. The temperature of the it's everybody is saying it's important, and it really is. But the pixel value is very stable. It's in a long range between 0 and 25 degrees, so more or less. It's very stable. You get always the same result. But the standard deviation, the error in your measurements, is really decreasing the cooler you get. When it is 0, it's just a value 3,000, and it's there 3,500. Another interesting, and it's looking like what you did there, I don't know, the stability of the light source in the night. And I did it 5 times in my own hometown and 2 times in a secluded place in the north of Holland. And I get always the same results. In the beginning of the darkness, at 7 o'clock, this was the 9th of December, it was very early dark, you get measurements of 400, and it diminishes in the course of the night till about 4, and then it is the darkest time of the night. And it has to do with all the local people going out and closing down their windows or their curtains or their lights, but also the ornamental lights, the signs, all the things are going down. And I find a really big reduction of light, about 1.3, about 1.2, I find in each night. And I saw in the SQM-LA measurement I did for the last 2 months also the same result. So it's probably very stable. Another thing, if it's stable into the whole year, no, it isn't. For instance, this snow, we have hardly any snow the last few years in Holland. But for instance, the greenhouses are not always there. So this is different results in different months for part of South Holland. I try to find it. I try to do it. The stability of the natural night sky. There's always an 11-year fluctuation. But also the ASO have found out there's also half-year fluctuation. I didn't know it, but I try. Hopefully, I can incorporate it in my model. Okay, and then my most difficult part, and there was somebody who asked a very difficult question about it. This is what I found. Fog and aerosols have a lot of influence on the measurements. They're really big. I've done 60 measurements in 10 different places, so 6 in each place, in different times, different nights. Most of the time I got reasonable, the same results. But sometimes it happens. It's gone terrible. And in general, when the extinction is higher, the lower stars are extincted, are not anymore visible, the higher the sky brightness you find. So you can correct for this. This is in the most nights when it is stable and very clear, you can have this result and you can compensate for it because you know what's happening. But sometimes it doesn't work, especially when fog is lower. For instance, I don't know. I don't know much about it. But I think when the fog is lower, for instance, we have got a stratification of aerosols and fog and transparency in different parts of the atmosphere, and then you get very strange results. It can be twice as high as 2 nights before, and I can now understand when it is, because my extinction measurements are gone hey then. They don't work. So I must throw those results away, because a whole night of work and I must throw them away. But that's one of the results I did. And otherwise, maybe if somebody has a receipt how to cope with this, maybe I can incorporate it in the coming year. I can correct for it. But I till now, I don't understand it completely. So, it is success. I think it's successful. It do what it must do. And I think it's the error in the range of 10%. The SQM probably 20%. I think I'm doing a little bit better, 10%. But in light measurements, normally they think it's rather good. A raster of 3 to 5 kilometers is enough. In towns, I'm now working for the city of Amsterdam. We do it for 2.5 kilometers. And I think that would be better. But in normal places, it isn't. And this is the things we can give for the local governments do it with it. They take those maps, going to recreational facilities and say, okay, here you are on a dark site, look at the map, what can we do together with them? Their own roads of the provinces are improved because of those maps, and the planning of new developments, for instance, new greenhouses, are done because, okay, this is also already a light place. We take it there and not in a dark place. These are kind of things they do with those maps. Okay, that was it.